To chapter 6, day 6. This shouldn't be a super long video, although I always think they shouldn't be super long videos, but let's see how this goes. So, special right triangles in trigonometry. The reason why I made this video is because there ends up being questions like this on the test, so I think it's worth knowing how to do this. In the last two lessons, you investigated patterns that can help you determine the lengths of the sides of certain right triangles. How do these patterns relate to the trigonomic ratios you studied in chapters 3 and 4? So today you will investigate trigonomic ratios by applying your knowledge of right triangle relationships. Even though this lesson is about trig, you will not need your calculator. So it says copy the right triangles right onto your paper and label the missing side lengths and measures. Then use the diagrams to write each trig ratio below as an exact value. And again, as an exact value means that we are not going to use decimals. So we're going to use fractions, and we are going to use square roots. So we'll get precise answers. So if I fill these things in, hopefully we all agree that this must be 60 degrees, that the hypotenuse is going to be double the 30-degree side length, and that the 60 degrees is going to be 1 times the square root of 3. So that'll look like that. And then here, this will be 45, so this must be 45, so this must be 1, and that this is going to be times the square root of 2. So hopefully we remember that from earlier in the chapter. So now it says find the sine of 30. Well, we're going to use SOHCAHTOA. And this is a pretty easy lesson, really, if you understand it. But I'll say a lot of kids really seem to struggle with understanding this. So hopefully this is the first part. Can we fill this stuff in? And hopefully we can, and we don't think it's very difficult. But if I want the sine of 30, it's opposite over hypotenuse. So opposite of 1 over hypotenuse of 2. So the sine of 30 degrees is 1/2. If you remember from the trig charts at the beginning of the chapter, we said it was 0.5. And there you go. It's 0.5. If I want the sine of 60 degrees, it's opposite over hypotenuse, so the square root of 3 over 2. If I want the sine of 45 degrees, it's going to be opposite over adjacent, so it'll be 1 over 1, which is obviously 1. By the way, I know that I said it's the square root of 3 over 2, but it just doesn't look very good right there, so there. All right, the cosine. Oh, I should be going ABC, and I went DEF. That's a bummer. Okay, so ADG. So the sine of 30 is 1 over 2. The cosine of 30 is the square root of 3 over 2. And the tangent of 30 is 1 over the square root of 3. Now, if you think about it, we have to rationalize that denominator. So we're going to get the square root of 3 over 3. Here, the sine of 60 is the square root of 3 over 2. So the cosine is going to be 1 over 2. And the tangent of 60 will be the square root of 3 over 1. So if you think about it, and not a big surprise, the sine of 30 is the same as the cosine of 60. We said that at the beginning of the chapter. The cosine of 30 is the same as the sine of 60. And these are going to be inverses. If you multiply these together, you should get, so the square root of 3 times 1 times the square root of 3 over 3, you should get 1, right? Because they're inverses. All right, so the sine of 45 is, oh yeah, I screwed this one up. The sine of 45 is totally wrong. Oh, that's a bummer. So the sine of 45 is going to be 1 over the square root of 2. I have to rationalize that denominator, so I'll get the square root of 2 over 2. The cosine of 45 is going to be 1 over the square root of 2. So again, you'll get the same answer. And then the tangent of 45 will be 1 over 1. So that was the one that was 1. I got that backwards. So I'll have to make a note in the description. So anyways, the idea is you will be asked to do this on the test. You will be given part of these special right triangles to fill in the rest, and then to fill in the sine, cosine, tangent using SOHCAHTOA. So hopefully not too big of a deal. All right, let's go ahead and actually, I think the last thing I want to talk about is the special right triangles. And again, I know we've already gone through this, but just wanted to draw attention. The 30, 60, 90 is as easy as 1 2 square root of 3, so make sure we remember that. The 45 is 1 and 1 is the same, times the square root of 2. And then we had the Pythagorean triples, where we know that 3, 4, 5 is going to be the same as 6, 8, 10. And 5, 12, 13 is going to be the same as 10, 24, 26. As long as they have those same ratios, they're known as Pythagorean triples.